Now that our circuit is constructed, let's go ahead and write some code against it. We'll start off by firing up WebStorm. Again, this tool is not required by any means, so you can follow along in any text editor of your choice. So we'll go ahead and open up that Cylon.js demo folder that we created just a little bit ago in our command line demo. I'll go ahead and expand demos, and then Arduino, and then here's our Cylon.js folder that we're going to be putting our demos in. Okay, then we'll go ahead and create a subfolder within here to contain our LED demos. We'll create a new directory here, and we'll just call it LED. Okay, now we'll go ahead and add a new JavaScript file to hold our LED demo code here. We'll just call this LED demo. And then we'll go ahead and clear out this generated comment here since we know who created this file. Okay, now first off, we'll need to reference the Cylon module, so we'll create a Cylon variable here to hold our reference. We will now be using the robot function to add a new robot object to Cylon. A robot is essentially a collection of connections, devices, and a work function. We'll see each of these pieces here in just a moment. To clarify really quickly, I've been using device throughout this course to mean Arduino, for example, but the definition in the Cylon context is more like electronic component, such as LED, button, motor, etc. And we'll see more of that here in just a moment. The first thing we'll add to our skeleton robot is our connection. Now you first do that by defining a connections property. Then we'll add a property, which we'll call Arduino, and set its value to an object with connection properties on it. The first property on this new object is adapter, and it tells Cylon the platform we are developing against. Instead of Arduino, the value is actually Fermata since it uses the Fermata protocol. The next property is port, and the value we give this is our serial port we looked up using Gort in a previous lecture. We saw COM3 on that scan, so we'll plug that in here. I want to point out something quickly here, and that's that the Arduino name we gave this connection can actually be anything, so we can change it to something goofy like Arduino Fuino and it'll work just fine. WebStorm's the only thing that's going to complain about it because it's not an actual word. I would just use something meaningful here like Arduino because you can actually have multiple connections defined here, so you want to know which platforms go with which connections, especially if they all use common adapters like Fermata. The next property we define on our robot is the devices property, and this contains a collection of devices with which we'll be interacting. For this particular demo, we're just going to be interacting with an LED, so we'll add one in here like so. Just like the Arduino connection name, device names can be anything you'd like as well. I would again recommend using something meaningful to indicate the component you are accessing. The first property that we set on our new device object is the driver property. This tells Cylon the exact component we are using, and it loads the appropriate definition for this device, which contains a suite of functions and properties specific to that type of component. In this case, we tell it we're using an LED. You can get a listing of the other supported drivers on their website. The second property that we define is the pin that this component is connected to. If you remember from our diagram, we connected our LED to pin number 12, so we'll specify 12 here. Now there's another optional property that we can slap on here as well, and that's the connection property. This associates the device to a specific connection, which is necessary when you have multiple connections, but not really necessary when you have only one, as Cylon, by default, will associate your device to the one and only connection. The final piece that we're going to define on our robot is the work function, and this is what is executed when the robot is started. Now there are a couple of ways to define your work function, and the first way is to define it without any parameters. If you go with this style, then to access your devices and connections, you'll need to use the this keyword, like so. Now Cylon aliases your devices and connections to make them accessible directly from this, like I have defined here. Or, if it makes more sense to you, you can go through the appropriate property to get at the object you need, such as this.devices.led. The LED device has a handful of functions here, and the first one we'll use is turn on. As the name implies, it simply turns on the LED by setting pin number 12 to a high value, or 5 volts. Since my preferred style is to use the device aliases, I'm going to remove devices from this line so that it reads this.led.turnOn. Now the second way to define this work function is to pass in a parameter which you'll typically see called my. What this is a reference to the robot we're currently defining, which is equivalent to this. Now this allows you to remove the this keyword by replacing it with my. The Cylon documentation states that this is more readable, but that's subjective of course in my opinion. Now I do use my instead of this, and it's for no other reason than that's how I learned Cylon, so that's how I'll continue developing. There's just one last piece we need to tack on to actually get this robot to execute. We go down here to the bottom and make a call to the start function, which kicks off the work function for each of the robots defined. Now with that, we have a fully functioning Cylon robot that will turn on an LED. Wee boggy!